All right, so we have a little bit of time, but I did want to mention a couple things about, nope, not binomial distribution. We're not going to talk about that. Not right now, because we'll talk about that probably next class in Monday when you do distributions. But permutations and combinations, just kind of quick raise of hands. Who remembers this word at least exist? Like permutations, combinations. Okay, now give me a thumbs up if you're like, oh yeah, I know exactly what this is. I know how to do it. Yeah, that's I like the thumbs down. Yeah. So I'm sorry, what was that, Liz? Is that
yeah, I know what it is, what they are. So
okay, perfect. Yeah. Sometimes I think this can get really confusing. Sometimes saying, is it a permutation? Is it a combination? So I'm going to give you guys a little kind of hint. Definitely go through the curriculum. It goes through it pretty well. There's also a video from Raphael, or no, well, Raphael did one too, but there's also one from Jeff that he kind of walks through and shows a bunch of this stuff. So I'll make sure to link that out on the Slack. And then also for Liz and anyone who's not on the Slack, you guys can look at this on the student resources available.
Yeah, I also remember how confusing they were though.
Yeah. So the big thing I would say, like if you want to remember what permutations is versus combinations, is that combinations are basically groups where order doesn't matter. Permutations are where order matters. So yeah, we have some time. You guys don't mind me kind of just going right into it, right? Okay. So again, look at the curriculum because it's gonna be a lot more detailed than what I can do in the next like 10 minutes. But if I had like different spaces, like it's like, okay, I have 3 spots and I want to put in, I'm trying to think how the best way to approach this. Let's say I have A, B, and C. And I want to say, what are all the different ways I can put A, B, and C in different orders, right? So for example, I have A, B, C. I also have, someone give me an order of A, B, C.
A, C, B.
A, C, B. Anything else?
B, C, A.
B, C, A. Anything else?
B, A, C.
B, A, C.
C, A, B.
C, B, A.
C, A, B. Good. Okay.
There should be 6 of those.
C, B, A. All right.
It's basically factorials, right?
Ah, yes, that's what's going on here. So good. Basically, factorial is like a quick way for us to do it. And the reason why it's factorial is really fun. Okay, the real reason why it's factorial. So first of all, thumbs up to know it's factorials. You know what factorials are? It might have been in the pre-course. I could be wrong. But 3 factorial, right? What is 3 factorial? Tell me what that is supposed to mean.
3 times 2 times 1.
Yeah, and I'll do 3 times 2 times 1. 1's boring. I never include it because it's just 1, right? But it is 3 times 2 times 1. Fun fact, back in when I was in university, I wrote a paper on this, or for my like bachelor thesis for math, which it comes from the gamma function, which actually is a more general factorial function. But we're not going to talk about that because
is it on the web anywhere? Can we read this paper of yours?
I wonder if it is. It's not published. I want to make that clear. I do have a copy of it still, a digital format. It was like a 20-page, exploration of the gamma function. All exciting stuff. Oh, and it was just, I think it was just real numbers too. I don't think I went into the imaginary complex numbers because then you get some weird, wild stuff. I don't remember now. Anyway, so factorial functions are really amazing, really quick things. The reason why it's factorial is like, well, okay, why is it factorial? Okay, the reason what's going on here, excuse me, what's going on here is that we're having the first space, the second space, and the third space. If I have A, B, and C, how many choices do I have for the very first one?
3.
3 choices. I can do A, I can do B, I can do C. How many choices do I have for the second one now? If I use the first one up, 2 choices. And of course, how many choices do I have left on the last one?
1.
1 choice, right? If I use A and B, all that's left is C. If I use C, A, all that's left is B. So that's what's going on here. You're basically just multiplying those parts, saying, oh, all those different spots, right? Okay. Now, if I have instead A, B, C, D, E, and F, but I only have 3 spots still, does anyone know off the top of their head what the permutation would be?
6
times 5 times 4.
6 would be 6 times 5 times 4. Anyone else got an idea? I'm not saying that's wrong.
It would be.
I think this is it. Yeah.
Go
It
ahead.
was like n permutation divided by n minus
Yeah, I
x,
see.
something like that.
Exactly. This is why I hate formulas, ironically, because it's so easy to forget, like, what was it supposed to be, like, and all that stuff. So the way you can kind of approach this, if this is my like cheating way of being like, oh, I don't remember what it's supposed to be, let me go back to basics. I say, okay, this very first part, how many choices do I have?
6.
6. Okay. Next one is, and of course we have 4, right? So yeah, Eric's is absolutely right. And I think if you do that real quick, what's that? 30 times 4, 120, right? Is that right?
Yes.
Yeah, okay. I want to make sure I started down to myself. Okay. And then I think it was Liz who was starting to say, hey, what's, there's a formula on it. The formula basically is ending up being 6 factorial divided by, what's it, 3 factorial.
Something, yeah.
Yeah, so if you go into that is 6 minus 3 spots. And so if you look at that, that ends up being, what's that? 6 factorial, oops, divided by 3 factorial. But that's the same thing as saying 6 times 5 times 4 times 3 times 2 times 1 divided by 3 times 2 times 1. And so what's 3 divided by 3? 1. So I can get rid of 3. Get rid of 3. What's 2 divided by 2? 2 or 1, right? And of course I don't care about 1s, but also 1 divided by 1 is 1. So you can see that's what's coming over here. 6 times 5 times 4. Is that? Oh, it's like magic. Math is magic. Okay. So it's basically just a quick way for you to do these combinations. So you can kind of see it's like, okay, what's going on? So this is a permutation. And we call it permutation, basically it's that you can order matters. When we mix AB versus BA, those are 2 separate things. If order didn't matter, whether that means like, for example, I think the curriculum talks about like you have 3 male students and 2 female students. The males are interchangeable. We just care if they're male or not, or if they're female. It's basically, oh, okay, these are interchangeable. So that's not really a permutation. Those are combinations. And so if you look at that, the formula, oh, I should tell you the formula for permutations usually is that you'll hear some, it sounds like Liz might be familiar, but if you have something like NP, oops, NP and then R, I think usually, or something like that, or K, sometimes you'll write it like this. There's a bunch of ways you can write this, depending how it is. But the formula usually goes, N is the number of different things you can choose from. So in this case, I had 6 different items divided by, what's it, N minus K. And K is the number of spots available. Usually it's like N choose, well, it's not really this way, but like essentially it's N choose K, right? And that's where this is coming from. And this is just basically a formula to summarize this so you don't have to, if you're basically, it's like, oh, this is a way we can quickly go through. If you try calculating this directly, like if you put in the computer, for example, let's say there's like 100, but there's 2 spots, there's 100 times 99 ways. If you try putting 100 factorial into the computer or a calculator, you'll notice that you'll probably get an overflow because it's a huge, huge number. So just be aware is that sometimes you can't just simply use this formula and stick it in the calculator, stick it in your computer, because it'll be too big of a number and you'll get inaccurate numbers, or the computer will be smart and say, oh, I can't do that. So you have to go down to this part. But dividing is really easy. So that's the formula for permutations. Combinations, all you're basically doing is you're, mathematically speaking, you're just doing the same, what's it called? You're doing permutations and then saying, well, some of these are the same. I don't care if it's AB versus BA. So you divide out those copies. And so for permutations, it's the same exact formula with N here, but you also divide it by K factorial. So this is kind of like one big thing. And basically that K factorial is just saying, hey, there's copies. And so you have less possibilities. Okay. That's a really quick, really quick of combinations and permutations. Definitely look through the curriculum. You'll walk through a lot more, a little slower than the past 5 minutes that I went through this. But honestly, all it is counting. It's saying how many ways you can make these different things.